So let's talk about the derivative for a parametric equation. So when we have a set of parametric equations, so we have something x in terms of t, and then y in terms of t. We'll call this g of t. We said yesterday that dy over dx is the derivative of y with respect to t over the derivative of x with respect to t. And this makes sense because if we were to do the keep change flip when we divide fractions, we would have dy over dt, change it to multiplication, and then flip that second one. You can see how dy over dx is going to come out of that. So then the question becomes, how do you find something like the second derivative? So to find the second derivative, we want to take the derivative with respect to x of the first derivative. And that first derivative was dy over dt over dx over dt. And we're going to think about this just like multiplying a fraction to another fraction. So we could think about this as d over dx times dy over dt divided by dx over dt. Just like we would if we had a number times a fraction. We could think about that being over 1. And then we could manipulate this so that this is d over dt times dy over dx over dx over dt. And that gives us a formula to find that second derivative. That second derivative can be written that way. So let's look at an example where we can apply that. Let's say we have x equals square root of t, y equals 1/4 t squared plus 4. Let's do t squared minus 4. Where t is greater than or equal to 0. So we're restricting y here to positive t values, which makes sense because I can only plug positive t values into this to get out real numbers. So we're going to start by finding the derivative, dy over dx. So that's going to be dy over dt over dx over dt. So if I take the derivative of this, I'm going to think about rewriting this before I take that derivative. So 1/4 t squared minus 1. So I bring that exponent down, so 2/4, which is 1/2. Subtract 1 from the exponent. And the derivative of that, -1, would be 0. The derivative of this guy, we would bring the exponent down, subtract 1 from the exponent. So those 1/2s are going to cancel, and this derivative ends up being t. And when I combine those exponents, I'm going to have +1 minus -1/2, which will give me a 3/2. So that's dy over dx. It's the derivative of that set of parametric equations relative to t. So now we want to find that second derivative. So to find the second derivative, I'm going to follow this format. So I'm going to rewrite my formula here. So I have d over dt over dy over dx. So I'm taking the derivative of this with respect to t is what that's saying. And then over the dx over dt. So if I take the derivative of this with respect to t, I would bring that exponent down, subtract 1 from the exponent. The derivative of x would be this. It is not the second derivative of x, it is the first derivative of x. So it's going to be 1/2 t to the negative 1/2. So let's do some fancy math here. I'm going to combine these exponents first. 1/2 minus negative 1/2 is going to be a positive 1. And we are dividing this guy by 1/2. So if I do keep change flip there, I'm going to get 3t as that second derivative. So that's how we would find the second derivative. Now, when we talk about arc length, our arc length equation is going from a to b, square root dx over dt squared plus dy over dt squared. And we're integrating with respect to t. Sometimes this integration is easy. We can do it by hand. Sometimes this is going to require some kind of technology to integrate. Let's look at a couple of examples. So we have x equals 6t plus 5, y equals 7 minus 3t. And this interval, t is restricted between 1 and 3. So if I want to find the arc length, this is giving me my a and b. The derivative of x with respect to t is 6. The derivative of y with respect to t is negative 3. I'm integrating with respect to t. So this ends up being 36 plus 9. So that's just a number, right? Negative 1 to 3. It's what, 45? So let's integrate with respect to t. So I'm going to have square root of 45t evaluated from negative 1 to 3. So we're going to have square root of 45 times 3. I'll put the 3 in front, minus the square root of 45 times the negative 1. I'll put the negative 1 in front. So this is going to be 4 square root of 45. And we could simplify that a little bit. 45 is the same thing as 9 times 5. And we know the square root of 9 is 3. So this would end up being, what, 12? I would be fine with either answer. Okay, let's do another one. I'll say x equals 3t minus t squared. Y equals 2t to the 3 halves. Going from 4 to 5. Same thing, find arc length. So we are integrating from 4 to 5. Square root dx squared plus dy squared. So if I take the derivative of this, I'm going to get 3 minus 2t. If I take the derivative of this, I would bring that exponent down. 2 times 3 halves is 3. Subtract 1 from the exponent. We're going to integrate with respect to t. So 4 to 5. Now I'm going to FOIL this out. Remember, that means 3 minus 2t times 3 minus 2t. And when I FOIL, I'm going to get 9 minus 6t minus 6t plus 4t squared. So that's going to be 9 minus 12t plus 4t squared. And then when I square this, 3t to the 1/2 quantity squared, that means 3t to the 1/2 times 3t to the 1/2. So this is going to be 9 when I multiply the numbers. And when I multiply these, when you multiply and you have the same base, you add the exponents. So it's going to be a 9t. So this ends up being the integral from 4 to 5, the square root of 4t squared. And if I put these together, I'm going to have a 3t. Negative 12 plus 9 is a negative 3t minus 9. Oh, sorry, positive 9 dt. So this guy is not going to be easy for us to integrate. We could try to tweak it to see if there's something we could do and use one of the formulas from the table, or we could use technology. You have the option to integrate definite integrals on your computer. I'm going to show you how to do it in Wolfram Alpha. I mean, not computer, I'm sorry, your calculator. I don't have a virtual calculator on my computer, so I'm going to show you how to do it in Wolfram Alpha. We're going to go to Wolfram Alpha. And you could just type in wolframalpha.com. And then we want to integrate square root of 4t squared minus 3t plus 9. Close my parentheses. That way it knows all of that's under there. From 4 to 5. So there it is. Double check, make sure we've typed everything in correctly. We have. And then here's your exact answer. Probably from one of the table formulas in the back of the book would be my guess. Here's your approximate answer. So that's approximately equal to 8.749. So there's our arc length. So I hope you found this video useful. Let me know if you have any questions.